Hey, who's here today? It's just me right now, I think. Who knows? If anyone swings by, let me know. We might hop in and do a little bit of coding right here. I've got some ideas. I was going to talk about recipes and stuff in 474, but we didn't have enough time. Let's go take a look at that. I'm going to look at some recipes for 474. Let's go look. But if you hop in the chat, let us know, because I am going to be checking out some recipes. We were talking about neural nets today. Awesome stuff right here. Some stuff. Hey, Demetrius, you got any questions you got? Just put them in the chat. Chapter 17, chapter 19, project, whatever you're thinking, Demetrius. Good to see you here. Stat201 representing right here. Whatever you're thinking about, let me know. We were talking about Mario Kart in the 474 class today and showing a great video by Seth Bling right here. Amazing channel, Seth Bling. Talking about, delete his channel. Lies. But he uses a neural net to drive Mario Kart. And it actually just comes down to equations. So if you're in 320, you probably have seen this recently. He shows it so quick, doesn't he? There it is right there. He shows it for like 2 seconds. The sigmoidal curve used in logistic regression to predict probabilities. So Seth Bling right here doing mathematical equations, showing how we can do it. He does it with like Mario also, so really great stuff. Follow-ups to his Mario video, and this is all using predictive analytics right here. So I always think this is kind of the fun stuff of what we can do with analytics is like literally write code that would solve Mario and have Mario, run through levels and figure out, oh, Mario got stuck. That's what can happen sometimes. So Mario's figuring out how to walk through, and this is just a computer playing Mario. General question, but when will the exam 3 review materials be uploaded? Should be uploaded soon. So I have them on the YouTube channel right now. Let's go here to my Stat201 YouTube channel. And for Project 2, can I use the similar? You can use the same variables throughout, like changing up what we're doing. We got 1 person watching, even though it says 2. It's 100 points to the chat. So go over here to the channel. And we do have some videos uploaded right now. Go to videos. I need to make sure we have the right videos. I'll go to playlists. And here we are. Exam. There's exam 2 speed runs. Test 3 speed runs right here. I'll probably be updating what's in the playlist, but I think it covers everything. There's conference roles. So I would be using these right here to go across. And Terry should have the material uploaded pretty soon right there, Josephine. Great job, Josephine, getting ahead. So here is speed runs. And I'll be posting this. You're welcome, Josephine. Speed runs right here. There's some speed run videos in the chat if anyone's watching. Got a few people watching. And exam 3. Did I call it exam 3? Might be more playlist down here. Exam list. Can't copyright claim myself. Test 3. There we go. Test 3. Oh, this is a great playlist right here. This is where I go through and do each. Mine's about the same like there. I go through and do each hypothesis test and talk through an example of each one right here. Like the 1 proportion Z test, each one of these I go through here and explain how to do it, explain what the notation is, and walk through and do an example step by step where we mark all the notation, walk through the example step by step, talking about each one. So it's basically like a mini lecture, no jokes, no fun. Fun is bad. We all know that. But these right here are reviews of chapters. Probably some of your better reviews right here. And really just sitting down and saying, tonight I'm just going to review one of these videos right here. You could put it at a little faster speed. You can always go here. A lot of people don't know the scroll wheel exists. You can go up here. I put it to 1.25, maybe 1.5. But then stay focused and practice and maybe pause and try doing it. And then the more you practice, the more you review, you're like, okay, wait a minute. This is the known alternative that we're writing. We're going to find the test statistic then. And after I get the test statistic, what are we going to find next? Yeah, let's do the acid rain next question, Olivia. You got it. And if we find a z-score, what would we then use that z-score for? So if you know the steps of hypothesis testing, you'd say, once I get my z-score, I'm going to do what with that z-score next? And we'll do the acid rain question here in a second. If we find a z-score, what would we then do once we get that z-score? I get a z-score. I'm now going to take that z-score and find my what next. So in the steps for hypothesis testing, Brian right here is finding his z-score. What's he going to do once he finds his z-score? He's going to use that z-score to then find his what? 100 points if anyone knows. I'll answer here in 10 seconds. Oh, I'm on top chat. We don't want to be on top chat. So once I find my z-score, I'm going to use that z-score to find my what? The z-score will be used to find the probability of if our results were unlikely by random chance given the null is true. The z-score will be used to find the p-value. So the z-score is going to be used to find the p-value. There's the z-score, and there's the z-score there being used to find the p-value on the greater than alternative. I can tell I used a greater than here because I'm shading to the right of it. What will we then use the p-value, which looks to be very small right here, to do? Since the p-value is very small, we are going to then reject the null hypothesis. There's the p-value of 0.002, and because the p-value is lower than 0.05, we reject the null hypothesis, and we see that our results were unlikely by random chance given the null is true. So I don't think the null is true because what I saw was unlikely given the null is true. Let's hop back. Good stuff right here. Let's do some acid rain question. Thank you, Olivia, for swinging by. Great question right there, the acid rain question. Chapter 17, acid rain question. Getting the question loaded up right here. If you have more questions, put them in the chat. We just got one question right now. So it's free questions after this. Tons of questions. Whoop, didn't click the assignments. We will... Demetrius, let me know if you have questions. Josephine, let me know if you have questions. Chapter 17. Replace questions. Acid rain. We haven't done the acid rain one this semester yet, I don't think. Oh, no, we did a while ago. I do know what it looks like. It's with the distributions. Here we go. Researcher collecting data on acid rain. Let's go take a look at it. Acid rain question, stat 201. So what we're looking at right here is 3 different samples, which is interesting because you might say, well, how can we do a 2-sample t-test if there's 3 samples? We can compare 2 of the groups. So this is almost like a post hoc test. If anyone knows what that means, that's a test you do after the fact if you were looking at multiple groups. So we're just going to do a post after hoc the fact test where we look at 2 of these groups. We're going to compare the M and the S group, which are going to be, what is the names of those groups? That is a mixed versus a shale group. And we're looking at the pH of these groups right here. On the project, yes. When it says choose a success story. Yes, exactly. Like a success, like could be like whether you like Taco Bell. Of course, liking Taco Bell will be a success. So yes or no is like one of those can be the success group. Like it's just like which group counts as the success group for what you're trying to examine. Great question, Demetrius. 100 points right there. And so we have the analysis done varying software. Now, this one is one of the easiest questions. I just need someone to put this in the chat. We can narrow this down very quickly and very easily for which one of these is the null hypothesis. What is the trick right here, which instantaneously we know the answer to the null? We've got here different nulls, and the answer to this one should be like, we should know it just like that, because we always have a saying about the null. Whenever we write the null for statistical notation, the null has Olivia right there, 100 points. The null has the equal sign. Great job. So that's pretty easy. We're doing a 2-sided alternative, which means we would shade both sides of the curve. We saw this earlier in an example I was doing just a moment ago, where I shaded the right side because I was doing a greater than test. I'm reversed image right now. So you would shade to the right side if you do a greater than test. You would shade to the left side if you do a less than test. But this is the 2-sided, which shades both sides because the does not equals goes both ways right there. So we have the null has the equal sign. I think I already have a little bit of notation up showing the null and alternative if we write it out. This is how we generally write the null and alternative. We have that the 2 means are equal, and then the alternative, if it does not equals, is the 2-tailed test. And when we find our results, we would take the curve and plot the t, and then plot something just as extreme and shade both sides. I do want to point out once again that we are shading both sides because of the sign of the alternative. If we wanted to see if the first mean was greater, we would do the greater than sign, and we would only shade greater than our observed result. So our observed result is right there at the line, and we are shading greater than because this points to the right. That's how that test is done. Remember, the sign of the alternative determines which way we shade when we're doing our p-values. Good to know later on. From the information you have, do the assumptions appear to be met? Well, so this is like where the rain is landing. I don't think the mixed and the shale care about each other, so they're not going to be dependent. The results we get from the shale is not going to depend on the results from the the mixed. So these are independent groups. That means one mean would not impact the other mean. To be independent means I know what the shale did. Does that tell me anything about how the mixed did? Nope. Independence assumption right here, that each sample is collected independently of the other one. It's pretty much your randomization condition. So we need to make sure we randomly collect our data and that each sample is independent. And this is not the groups are independent, but each sample is independent of the previous sample collected. We're not going to like the same spot and taking a bunch of samples in the same area. We're going to like different areas around this lake where we're doing the investigation, I believe, the stream. There it is up right there. So we're going to different areas around the stream and getting independent observations that are completely random from each other. We're just saying, here's a map of it, and we just put different dots around the map, and then we say, let's go grab these random samples from these different areas, and then we see if it landed on shale, mixed, or limestone, and how it did. So they're completely independent, they're completely randomized, and that's what we need to run our test. Nearly normal, this is probably the hardest one to check, especially with this data. There's a little bit of a right skew to this one, a little bit of an outlier. I can't see where the median is at on this because the median is either on the 25th or the 75th. The box plot shows that it might be right skew because there's that. So the median might be down here. This is probably my biggest qualm right here with sort of this online question. Do we have the sample sizes? T-statistics with degrees of freedom 42. Sample sizes probably like in the 20s for each group, upper 20s or something. You can kind of get an idea what the degrees of freedom are by how, or what the sample size are by the degrees of freedom. I don't love this question right here. The answer is going to be yes, but we'd want to go into more specifics. We'd actually want to look at the distributions. What do I mean by that? Well, if we have two quantitative distributions like we have up here, to check the nearly normal condition, we actually need to kind of look at the shape of them. And although these are not perfectly normal for the sugar content of adult and children's cereal, the condition of nearly normal states that the distribution of the mean will be nearly normal if the sample size is large enough. Now, these come from groups of about 25, which is what we have for our example, and there's a little bit of a skew, like there is for our example, but because we have a large enough sample size, the distribution of the mean for these groups will be nearly normal. And that's pretty much what we're doing in this example right here, but we can't see the data as well. So I should ask, is it plausible right here? It's plausible. I don't think we have a major issue. I think we're good. Now, the last part of this is asking us, what do we do with the null hypothesis? So take a look at the p-value here. The p-value is what? It's very, very what? And think to 0.05. That's when we say it's this to 0.05. 0.05 is basically your unlikely result. Like this would only happen 5% of the time. So it's pretty unlikely. Like there's a 5% chance of rain today. It's pretty unlikely. So how does your p-value look to 0.05? It's what-er to 0.05, which 0.05 is unlikely. Your p-value is what-er to 0.05. Higher or lower? What would your p-value be? It's very, very this, which means it's very, very unlikely. What you saw was very, very unlikely. It's very, very lower. Great job, Olivia, right there. It's very low, super low. So that means you super reject the null. We don't say that in statistics, but we should. It's very low. I really reject the null hypothesis. I got tons of evidence. What we're doing right here is we're comparing the means of these groups, and we reject the null that they have the same mean. There is very strong evidence that there is a difference in the pH levels right here. So I reject the null. I have evidence of a very big difference, and that's just by the p-value right here. The test statistic is 6.4. So if we drew this out right here, what it would look like is we'd actually have to zoom out a little bit and draw our curves smaller. Generally, T and Z curves only show to about 3, so I really do have to zoom out on this. When you look at your T and your Z curve, you generally only draw to about 3. So you'd go here and go 1, 2, 3, 4, 5, 6, and the curve should be really down here by this point. So our result is all the way over here. I think it was at like 6 or something, or 5. Let's look at that result again. Our result is at 6.4. It's all the way over here. That's where we landed. Our result just as extreme is all the way over here. So our p-value is an area we can't even see. Going to a t-applet, we would see the same thing, but remember, we generally only see within about 3 standard deviations on the curve, or standard errors since we're doing t-scores. So really, we're so far off the curve right now. It said a t with like 25 degrees, no, it was like 45 degrees of freedom, and we landed at like a t-score of 6.4, and we're doing the two-tailed. You can't even see it. The graphics won't even show it. Statistical software would have to be used to calculate the p-value right here, which is going to be very, very tiny. A quick artistic rendition of it is going to show something like this, which is way off the curve. You don't even see where it's at, we'd have to bring this down into like 2.5 to see it on the curve. But once again, we didn't get that t-score. We got something way off the curve. So yeah, basically this is impossible via random chance. So there's strong evidence of a difference right here. Very, very strong evidence of a difference. Next question, just ask away. It's open floor for questions. Put those questions in the chat. I might go look at some recipes. Recipes? What? You're welcome, Olivia. Great job right there. I should go look at some stuff I want to look at for... Such a crazy package. For the bimodal, the two peaks have to be the exact same height. Which variable you're analyzing, Demetrius? They don't, like... Things can be slightly bimodal. You might say that, like... you could say it's somewhat unimodal, but might have slight bimodality. Like, don't always think about things as a... So here, let's talk about this. Talking about shape and center of data. We'll put a little section in this video. The shapes of data. Let's go look at the shapes of data right here and talk about those. Good questions. So don't think of a shape of a data as 100% unimodal, 100% bimodal. You can see different ones right here that are clearly unimodal. Let's go look at this distribution. I think it was 20. Let's go look at all the quantitatives. Let's analyze all the quantitative variables we have in the data set. And here they are. There'll be some clear, easy to see shapes and some not so easy to see shapes. And, ooh, got some colored the points in there. Okay. So we're analyzing every single distribution right here. And we'll just get it nice and big so we can see each one. This data set for 100 points is very, very what? We wouldn't analyze it. It's an identifier. This data set is 100% this. Like this. And now don't be tricked by this over here. It's just the bin or whatever. But this data set is as this could get. This form, which you won't analyze an identifier. We don't really make graphics of identifiers, do analytics on them because they're used to identify. And hence it has this shape. Who knows this shape right here for 100 points? I'll take a pause. This shape we should know, it means one form. This is as blank as this could get. It's almost a perfect one. It's just by virtue of some of the values in the bins. We could probably make it so it looks perfect, but it's as this is this good. I might answer the question myself. Uniform. Not unimodal though. Great job, Demetrius, right there. Demetrius, I'm throwing you another 200 points on that. Thank you, Demetrius, for being here and answering these questions. This we would just call uniform. So to be unimodal, you must have a peak. So unimodal means like one central area, but it's just going to be uniform. So we won't blend together. Does that make sense? Uniform means one form, like this is flat one form. Unimodal means one peak. So we don't see modality to this, like a modal area. We see just one flat form. So we see a uniform distribution right here. So it's one form. Think about it, it's just flat across. It's one form. Is it perfect? It actually kind of is, because if you look at the data this came from, the original data is just numbers. And this is how a uniform distribution looks. These numbers right here that just go like that is just completely flat. And that's how we get the uniform distribution. Yep. And then this is a good example of what are here. This is age of students. Now this is, I'll explain this one. This one is very, very unimodal, and there is a little bit of right skew. Actually, more right skew than a little bit, I should say. You can see right here, the mean is higher than the median. The mean being the average age of students in this data set. Not just say the mean is 19.58, but hint, hint, hint. The mean is the average age of students in this data set, which represents a student of 19.58 years of age being the average student. The standard deviation gives us a general spread of the data from the mean, which is the value of 1.06. So it's an idea of how far out the values are spread around the mean. Once again, let someone know, rather than just saying the standard deviation is this. Tell someone the standard deviation shows us how far out the data is spread around the mean. It's an idea of distance around the mean for the points. And that would be the proper measures. It has some skew. If we say it has a good bit of skew, we're going to go with the median and the IQR. I'm keeping to this one saying it has some skew and light outliers. That's the hardest part. This is the subjective nature. And tell me if you think any of the graders are mean, because I can always take a second look. When I describe this one, I'm going to say it has light skew and light outliers. I'm still sticking with my mean and standard deviation. Another statistician would talk differently about it. This one right here also is an iffy one. It borders on it because it's got a good bit of outliers, but we're also dealing with a data set at 806 points, and 0.3% of data points would be more than 3 standard deviations away, because 99.7, 68, 99, 95, 99.7. So we would expect some outliers here with a large data set. We'd expect about 24 outliers, and we have more than 24, it looks like, but and especially that person down here with a 1.8, that'd be worth mentioning. At this point, I might border on using the median and the IQR. The median being 3.85. This might go over to that because I'd say it's got a little bit of left skew. That's actually the mean right there and a confidence interval for the mean. So you can actually quickly look at these if you look at the median, which is the line in the box plot, and JMP makes the mean the diamond. So does that make sense? You can see there's more. Oh, that's got even more skew because I think that's the median. It's iffy. This one's there's no debate on it. This one, what it would use right here, median or mean. And so we'll interpret that. This one is unimodal right skew with extreme outliers, and this is how many pets people own. There's no debate about what to use here. There's no debate. If you don't use this, then you get it wrong. And don't mention the other ones. The proper measure of center for this distribution is clearly the what? I'd probably say that. The proper measure of center for this distribution is clearly what? So this is ridiculously skewed. There's extreme outliers at a value of like 19 or so. We can actually find out what that person has by hovering over 18. Yeah, I would not explain the average. Yes. I would only talk about, so I would say the proper measure of center for this distribution is the median, which represents the 50th percentile of pets owned by individuals, is 1. And the proper measure of spread for this distribution is the value of the IQR, which is 2, representing the spread of the middle 50% of pets owned by students. Does that make sense right there? So make sure it's very clear what is the IQR. Don't just say IQR is 2. The proper measure is median is 1. The proper measure is IQR is 2. That could lose you points. We like to say the proper measure of center for this distribution is the median, which represents the 50th percentile of pets owned by students, being 1 pet. The proper measure of spread for this distribution is the IQR, which represents a spread of the middle 50% of 2 pets, and that is the distance here of 2 to 0. The middle 50% going from 25 to 75. That last part right there, you might not add on. Another clear distribution using the median again, and IQR is proper measure of center spread. Another clear one right here. This is still very skewed. This one right here, this is where I wouldn't really say it's bimodal. It's still just really modal around this area of about 15 to 16 credit hours. This one I might median there, mean there. It's got a little bit of right skew, but low outliers. This one's like a funny distribution. Haha, funny. But I don't know. It's toss up which way you could go. This one has extreme high outliers. I'm probably going to go with median and IQR here. Due to the high outliers and extreme, there's some right skew and there's extreme outliers. This is how much money you expect to make. So the proper measure for center of this distribution is the 50th percentile of students expect to make $60,000 when they graduate. And the proper measure of spread would be $20,000, representing the spread of the middle 50% of the data for students on how much they expect to make. Very clearly median and IQR. Probably still median and IQR. You got a little bit of low outliers, but extreme high outliers. Weird distribution. Still median and IQR, I'd say. This one I might... someone sleeps 15 hours a night. Really? They are awake for 9 hours a day. That'd be like getting up at 9 a.m. and going to sleep at 6. Maybe, I don't know. Maybe. Collect enough data, see something weird. That's the way life goes. How far is the... If it wasn't for that person, I might go mean and standard deviation. Because that person, I might go median. Like, it is the sample of 806. Median and IQR. Aloha, Ditto. Feel free to ask any questions. We're just looking over some distributions. Median and IQR. Median and IQR. Median IQR. Median IQR. Median IQR. Median IQR. Median IQR. Median IQR. A lot of those are pretty easy. Some of them are more toss-ups. Does that make sense, Demetrius, as I go through these? And I see like high skew, extreme data points, like things like this are pretty obvious median and IQR. So there's ones that you will see where it's pretty obvious what they are. But then there's some like ones where you kind of get into iffy ranges. I wouldn't call something like this bimodal. It's mostly unimodal. It's got a little form, like little bit of uniform, like it flattens out in some areas. It's just a weird looking distribution. But also the bin widths can change that. Thank you so much, Demetrius. Great work right there. Like if you change the bin widths, now it looks extremely unimodal. Remember, bin widths control how much data go into each group. So just changing how much data goes into each group changes the way it looks. For the 2-sample t-test, I don't have an option for the t-test. Oh, let's go take a look at that. Let's go talk about some 2-sample t-tests. Louis, thank you for asking that question. 100 points, everyone in the chat. Ask all those questions. It's open floor for questions again. Let's go do some 2-sample t-test. So for a 2-sample t-test, how many variables do we need? Let's go do a 2-sample t. How many variables do we need? So, interestingly enough, for a 2-sample t-test, you'd be shocked. We need 2 variables. And that's not actually why it's called the 2-sample t. We'll talk about why it's called the 2-sample t. We're going to go here to fit y by x. Fit y by x is going to have us predict a y variable on the y-axis with an x variable being the explanatory variable. So let's go here to the fit y by x. Now, the reason it's called a 2-sample t is because we have a categorical x with 2 levels. That's why it's 2 samples. We have a group this and a group that. So we want to go here and choose something like Greek life. This has 2 groups. It has the yes and the no group. We can probably see it if we do. There you go. There's Greek life right there. It's blocking on my screen a little bit. I don't want this right here. Sure. It's going to block my screen. We got Greek life, yes. We got Greek life, no. There's more individuals in Greek life, no. Doesn't really matter right now. Rock, you hear, man?
It doesn't matter.
He knows. We're just going to put this right here as the variable. This is our 2 samples right here. We have a sample from Greek life, a sample from not Greek life. Now we're going to compare them on a quantitative y-axis right here to say, well, like, who owns more pets? We've got a pet company here, and we want to sell pet supplies to you. And we want to know who has more pets. Or better yet, who spends more money on their pets? Is there a true difference in the average amount of money that a Greek life person would spend versus a non-Greek life person? Does that make sense when I'm asking? I'm like, okay, I got my Greek people, I got my non-Greek people. Who spends more money on pets? The null hypothesis is going to be that the two are equal, where the alternative would be, let's see if there is a difference. And the answer is, well, here's our data. We got some right skew nature to the data. I'm going to go ahead and clear row states because I colored the points a while ago. We just want no coloring right there. And let's go ahead here and take a look at what's going on. And this is where you want to click right here. How's it looking, Lewis? Did this fix your issue? Did this fix the issue for the 2-sample T? Can you now click the button? There should be the option for the T test. So, Lewis, let me know if you followed the steps right here to compare 2 groups, like a yes group or a no group or a freshman. Are you on the Discord to send me a screenshot of what you got? Are you under the Fit Y by X platform? If you're under distribution, there won't be t-test. You have to be doing a Fit Y by X. So I'll go through the steps again here to get to this point. We have to go to Analyze Fit Y by X. With Analyze Fit Y by X, make sure to pick a 2 level. Make sure it's 2 level. So you need to pick a 2 level, something like Greek life, which has 2 levels to it, and put that in the X. Next, and then did you pick a 2 level categorical here? So you have to have a red variable here. This needs to be red with 2 levels. So you see how Greek life has 2 levels. That's a red 2 level. And then you want to pick a blue quantitative. So this Y variable has to be blue, like how much people spend on their pet. This has to be blue right here. These colors tell you the variable type, telling you this is categorical. We can also see it's a 2 level categorical by looking at right here. I clicked that button to see the distributions on it. But also if you have something like on campus, off campus would be 2 level. So it has to be a 2 level. And then this has to be blue for quantitative. There you go. And so there you go. That would be the issue. If it has more than 2 levels, there you go right there. I think you're using the donor data set, right? I think that has like you or other things in there. Real data working with right there. You never know. And so you want to have the 2 level right here and then click right here to the t-test. Awesome. Yep. And what would we see? It's a close call right here, but really, is there a difference? What do you see about this interval? Now, the group that spends more on their pets is Greek Life. In our sample, we saw that Greek Life is spending more on their pets, but what do you notice about this interval right here? In this interval, we see that the interval contains 0. So it's possible the difference between the two means could be 0. Because I'm 95% confident the difference between what Greek Life individuals spend on their pets versus non-Greek Life individuals spend on their pet is contained in the interval where non-Greek Life might spend $7.15 more, or up to Greek Life individuals spending $418 more. And I know the interval is more leaning towards Greek Life individuals spending more on their pets, but it's very important to know that 0 is in this interval. 0 being in this interval means it's possible there is no difference. Like, that's a hypothetical value. So if you test the value of 0, could we actually do that? Can we do a t-test? Well, that's the t-test right there. I don't know if it'll let you test your own value. We are testing 0 here. We're testing 0 anyways by default, but I wish it would let you set the value you're testing. There might be a way for Jump to have you to do that. But right here, we are testing the value of 0 and we do not reject it. It's a close call. It's a close call. But we don't reject the value of 0. Why do we not reject the value of 0? The p-value is above 0.05. Remember, the p-value is showing us how probable our results are by random chance given the null is true. The null for the 2-sample t-test is that there is no difference between the two means. We were doing a different test here just a moment ago, and we're also doing a does not equals right now. So really, every time we do this, it's really just mean 1 versus mean 2. We might have subscript denoting what we're talking about, like if it was Brian's bars, we were talking about that yesterday. We're doing the does not equals test today. But we're just seeing the difference right here between mean 1 and mean 2, assuming there is no difference. And remember, we don't reject the null hypothesis, so we're going to continue to believe there is no difference. And that's via this p-value right here for the does not equals. This is the does not equals, this is the greater than, this is the less than. And that's got it. Well, let's head back right here. It's open floor for questions again. Open floor. Drop those questions in the chat. I might go look at some recipes right here. New package. And that's why I know his name. I think he does other packages. He's a data science engineer. What? Yeah, and let me show you something here, Snail. Let's go talk about that, and let's go look at that time series cross validation, because I have no idea why it's taking so long. I've got an internal on mine. This is something I've been experimenting with, Snail, in the background. Is if you look this year, it's pretty recent. This is recipes right here, and so what people do is they write the recipe to create all their models, and we really should start incorporating this right here. Looks like he's doing a stepwise. You actually bake it. This is what nerds do. I mean, I'm a nerd, so. And they're using the complete, always not complete cases. So doing all this right here, making the recipe. Yeah, so, and they're piping it all through dplyr. So they have like these steps right here to remove all things. So it does a lot of Petrie's code with like they're doing a principal component analysis right here. So, and then getting the principal components. So doing a PCA right here. We haven't even done PCA. PCA is dimension reduction on your X variables. So, but no, the recipes package is pretty cool, and I want to look through that. So let's go ahead and take a look. So with the time series cross validation, we're doing like the Tizble longer. It might just be my computer then. Yeah, let me go. You send me your current file, and I'm going to run it here in the background. And I'm going to check your code first, too. Send me your current file. I'm not going to show it off, because some groups, I'm going to mention this in class today, some groups have some errors. Some groups have some errors. I've kind of alluded to it. Some of the errors you'll see. I don't think your group has it. I've been kind of pointing to some groups. So send me the code SNEA via, I'm looking across the messages on Discord. Drop me the code. Oh, people are. Payne's asking about the forum. Oh, yeah, the forum is today. Oh, my gosh. So many things are going on. People talking about the Bachelor discussion right here. 100% right here. Let's see right here. Awesome. Snea just dropped me the code. Let's take a look. Okay, I'm going to try. Oh, I don't have Fable Prophet. Which one is Fable Prophet? Package for... Wait. Oh, I think you must have it down here. There it is. Fable Prophet. What is Fable Prophet? What is Fable Prophet? It was for the profit model. What is it again? I see the profit model right here. I haven't done that lately. Advanced forecasting. Oh, it's at the very end. Yeah, because like he just released FPP3 at the start of this semester, so I've read through most of it, and I've done the neural nets at the end. So I didn't do the profit. Did you get anything go with the profit model? So I haven't done that yet, but great work, Snail. Looking there at the end. I love his code. It's just so plug and play. Makes it nice and easy. I see you've got your Fourier models right there. All that good stuff. Got your Holtz, got your Winters, all this good stuff. Frontier is always like, we see that there's problems. I'm going to see if your data has... Snea, what trend are you noticing in your data? I just want to mention something right here. What trend are you noticing in your data? I'm looking at your models. What trend are you noticing in your data? I just want to make sure all groups see this. Very important. Since you're hearing that. So it was worse than the ARIMA. Yeah. ARIMA's pretty traditional. What trend are you noticing in your data? What trend are you noticing? What trends? I'm going to pull it up right now. What trends are you noticing? I don't want to quite say. I don't want to be like, this has... I want to allude to it. Let's read this. Our company, Volunteer Camping, has been in business since January 1950 when Kevin Lee founded the Camp for Teenagers. Over the last... It's not stationary. I totally agree with that. Over the last few decades, we've seen growth in the utilization of our camps, and our profits from the camp have also increased. We're looking to predict the sales for next year to make a better marketing strategy. If you could send us back your predictions for the next year, that'd be great. Also include a PowerPoint in your presentation. So they're making it very clear. This gentleman right here, Kevin Lee, great stuff right there, is making it very clear that what's going on with the data right now currently. What's going on currently with their data? Very, very clearly, it's what? I don't want many groups to have this error. So, is that... the sales are well, so is that what you're seeing? Or is that what he's... So what are they saying to you? What have they told you? Because the biggest thing is sometimes we get data and the data is not like the way it should be. I'm the person who wrote this email to you. I can 100% confirm to you that the sales are increasing. 100% can confirm that. This is not a lie, not a trick. The sales are increasing. I've been speaking to this company and say, yeah. We can look at the data right now. We know our sales are increasing. From 1950 to 1990, excuse me, our sales have been increasing. 100%. Business is booming. Ditto knows it right there, 100 points. Why might they be showing the opposite? You can, because when people send you data, They're not going to think about like you're going to load it into R, right? Do you get what I'm saying, Snap? There's ways to fix that. So we always have to be very careful. And I've run into this. I'm working on a project in the background right now, and I've run into where I didn't know enough about the data, and I made an assumption, and I did things in wrong, and then we were like, wait a minute, this means something totally different. The biggest thing is like your data might not be the way you think it is. Like if you load the data in, you have to make sure it is the way it is, and you have to look at the context of the data. So don't worry, like this is a small fix which can be change everything pretty quickly, because it'll change your model obviously, but it's not that hard to get the change in there. Does that make sense? Yeah, because it just depends on how a company stores their data, right? Companies might be doing that. They might have their most recent data, and they might not have it in the right order for you. So you can fix that when you have to run it. Because the problem we run into, and this is just the bummer about it, is a lot of people don't do data management, so they're going to not have the data stored the way that we would load it into R. Luckily, this is one of the less messy data sets. Like in terms of messy data, this data is about as nice can be, because it's a simple fix to get everything nice the way we want it. You know, we got to put in the dates and stuff like that, but overall, this is not too bad. Like they're like, oh, well, we've been collecting our data. And frankly, if a company had data that looked like this, you might be pretty happy. Like, especially if they did from like 1950, you'd be like, you've been collecting this data since 1950. And you put it in a spreadsheet for me. That's really nice. And then they only have one error really that we got to fix up, one error that we got to change over and get things working properly on it. So make sure to do that, or else your predictions will be completely wacky. And the naive model would do better. So you don't want to lose out to the naive. This can, yeah. Maybe some other groups are watching this right now. We've kind of said what the issue is. This is a big catch, which can dramatically destroy someone's model right here. Big tips right there of what's going on. Very important right there. Yep. No, I'm glad you saw that. Thank you for coming by and asking. Groups can tell other groups. I'm not holding back any group from not telling another group. I've mentioned to other groups. I've said, that's weird that your sales are decreasing. We're seeing an increase. Adding the dates took so much copy paste. Well, it shouldn't take copy paste. Well, you shouldn't need a copy paste. You should just you should be able to put it in as a Tizble, right? You should be able to pipe this in as a Tizble. And Martha, great to see you here. If you have questions, Martha, let us know. You should be able to get it in as a Tizble. So yeah, pipe it as Lubridate. Yeah. Let me go take a look right here. And then you just need to do a little like reverse or rev, REV. Yeah, exactly. And then snated the length. Yeah, that's exactly it. Oh, and then you did the... And then you renamed the columns. Excellent work right there. And then you piped it through, used the mutate. And so, yeah, you added on a date and then ran it through. Yeah, 100%. I'm not going to show it because I want other groups to think through. But the process should be pretty clear. Load the data, add a date column using the sequence function as.date. We've done that a few times in class, going by month. And then changing the names, I think, is a very good idea. Good names right there. Pipe your data through into a Tizble, pipe it through a mutate. And then, yep, you've got it right there. And then you've got your Tizble. And then check the object you've created to make sure it's a Tizble. And that's got it right there. Like really what you want to get to do is you want to make sure, I can't show it. I don't want to show anything too much. For the 2 sample t-tests, do we need to include all of the output or just the... I'll show that here in a second, Martha. Great question. I'll show that here in a second. So let me try this. Let me run this in the background here, Snea, while we do this. Let me go to your stretch. Here's your stretch. Okay. I'm going to run all your code before. Let me try running the stretch Tizble right here. Okay. Because the stretch Tizble creates like a huge data set. And that's usually where we run into the problems. And then Martha will go look at the next one. It's running the neural net currently. I don't want to show any of this, so lest other groups, like each group, you got the Lambda. Yep, kind of mentioning some ideas so other groups could listen and get some ideas. Like, I'd look for a Lambda transformation. Let's see right here. It's still running neural net. Running the. Yeah, I don't want to say all your ideas. I'd run a neural net. I don't think that's too much to say. Run a neural net. Oh yeah, Lubridate is amazing. Lubridate working with dates, and that's a tidyverse package right there. Neural net is taking a good moment here. I think we might be good. I'm gonna stop the neural net. Is that like right before this? Yeah, it is right before it. Nice job. Nice job. Yeah, it wasn't too bad, right? Wasn't too bad. Pretty easy fix right there. Okay. Let me stop this. Okay, good. Yeah, with the Stretz Tisbol, it creates a really big can't show any of this because I don't want people to like see. It creates a huge object. It's just ridiculous. It's 121. Yeah, exactly. Now take a look at how they're doing because that's going to change a lot. Snea. Your neural net took a while, so you're running immediately your cross validation on your neural net. I wouldn't run your cross validation on your neural net first. I think that's part of the problem. You're running it on your neural net, and that's such a big thing right there. Like, that's huge. So I think that's part of the issue. Model. Okay, I think that does it. Yeah, the neural net takes a moment, and then look at the size differences with the one sample Z and one. Yeah. It can be the yes, it can be the no. Great question right there, Ian. It can be the yes or the no. Like success is like maybe we're looking to see if students drop out of school. So a success might be not like, let's say we're trying to reach out to students who could drop out. So success could be not dropping out of school. So success and failure is completely subjective. Does that make sense, Ian? Like, what is a success? It's whatever we define as like, what is the thing we want to observe? So there's two groups, and the success would be the group we want to observe. So it's completely subjective right there. Very, very subjective. Let me change this. Okay. I'm trying to get it. Okay, it actually works right here, Snay, on this. Okay, I don't think there's too much of your code to show, so let me run this and show you this right here. The code is working. Is it okay if I show, this only shows a bit of your code right here. It shows your TSCV accuracy, but I'm doing it differently. So are you okay with me showing this right here? It does work, and I'm using the easiest to model. Interesting. That is interesting, right? As long as you're okay with me. Yeah, this is not too much right here. Let me delete off the graphic. This is so very little. People couldn't even run this without the other code you've created to create the objects. So I don't think this is too much. Oh, we're zoomed in. So the code is working, but running the neural net through the cross validation in time series, you can just see the object size. The original sales data right here is like 492 observations, and the size differential is 121, 275, 492. It is 246 times bigger. So like you would think, I think it's exponential growth on time though. So then what if I want to check my chosen model is overfit? We can do some time series cross validation, but we might not be able to do it on all. Maybe try different stretching of the Tizbol. Like try a different Tizbol stretch. Let me look at that real quick. Because if we do a different stretch on the Tizbol, so let's initialize on 20. Nah, it doesn't really change it much. Okay, okay, this might work then. Let me look at the Tizbol stretch on this. Okay. Okay. If you change your where you initialize it and do your like a bigger values for where you initialize and step. And so I'm going to try to run an ARIMA on this now. I'm going to try to run an ARIMA and see if it works. And then we're going to do a little more 201 right here. So I'm going to try to run an ARIMA model for you and just see if I can get to work on. So I'm changing the initialize and the stretch values on the Tizbol. And then I'm going to run an ARIMA right here with the PDQ. I'm just going to run the white noise ARIMA just to see if it works. White noise seasonal ARIMA. And okay, let's see. Oh, it actually ran really quickly, but it's giving no estimates. Like, it's actually not running at all. So could not find function PDQ. What? Oh, did I choose the wrong ARIMA? Say my PDQ doesn't exist. Oh, PQD. Wow. You can't see it right now yet. Okay, yeah, it actually works, Snea. Here, I'll show you. I changed the parameters on the steps. So I changed what's going on with the model right here, and I'm actually able to get the model to work. Does that make sense, Snea? With this right here, and this, I don't think this is too much because we're basically showing a lot of the code we've been doing with making a model. People have to make their own tables, figure out the issues with this data, and this is just a random, so I definitely changed the Tizbol stretch right here with the lengths of it. So there's probably some exponential growth to time its creation, and changing the stretch Tizbol to initiate and stretch in different ways is going to allow us to actually do this. So what's the right to initiate? What's the right value to initiate on? What's the right stretch of the Tizbol? Well, that's going to depend on the data you're working with. Did you do... Yeah, I think here, I'll tell you. I have 20 and 7 right now as my parameters for the values for it. I don't want to show that code too much because that code kind of leads into this. So that code, which like this code only works if you have that code. Well, or you could just be making an ARIMA, which I think hopefully people know right by now how to make an ARIMA. We've been covering that a lot in class, so I don't think this gives away anything really special right here. Exactly. So you're like, yeah, I know what you're talking about. You're changing the parameters for the stretch Tizbol, which we've covered that some, but I want to make sure people know what you're going on. So that's going to control kind of where you're initiating the stretch of the Tizbol and how much you're changing the stretch by, which you can actually see if you look at the values inside of here. You can see how it created the different stretch of the Tizbol. And there's a lot... like we get through this values a lot quicker. It still takes 17,000 values to get through the whole data table, but it's actually able to go through it a lot quicker than with the other ones. And it's way, 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 way able to work. I think there's exponential growth. You could play around with the stretch values and see what you get. So probably, the more stretching you do of the Tizbol, the better cross-validation you're going to get, a better estimate. But what's our RMSE? RMSE looking pretty good. I mean, I don't know, maybe. Random ARIMA model. Maybe this is the best one. I don't know. Would be interesting just to do the search on it, right? Probably have done it. So check that out. Give it a look. And great work. We'll head back to the main screen. I'm glad we were able to figure that out, Snea. It's like just looking through there. I figured it had to be... it could also be your computer's just kind of running out of memory. So... literally, and one of the best things, I should talk more to Nick about this. you can send these things off to like the Y12 supercomputer, and like you can just buy server time. What do you mean by stretching the Tizbol? I don't recall that. That is time series cross-validation. Ditto. Double check the time series cross-validation for the function stretch Tizbol. And stretch Tizbol is going to allow us to do time series cross-validation, which will be on the final. You have to understand what is time series cross-validation. It's a way for us to get an estimate of how the model would work, making predictions. You're like, I just bought a new computer. But do you have a Y12 supercomputer? Really, we just run into areas where no matter how good our computer is, the exponential growth to models can, like we talk about in 474 especially, the tuning parameters. Every time you add a tuning parameter, you exponentially grow the model time, like how long it takes to create the models. So there's no computer that will ever be able to do everything because tuning parameters are pretty much infinite for especially really complex models. Yep, definitely take the book notes. Excellent stuff right there. The Tizbol, the stretch Tizbol, the time series cost validation. Good stuff to do. Got some tips right there. So you didn't get to see that code, but you got to hear about it. So good advice right there. Awesome stuff. Let's go see. We have some 201 questions. I think we answered Ian's. Ian, let me know if we didn't answer it. Yeah, try making it so you have a much smaller Tizbol and then grow the Tizbol more and see what you get. Martha asked, for the 2 sample T, do we need to include all the output or just let's go look at the 2 sample T output. Here we go. Let's go look at 2 sample T output. Boop. Can you were looking for the executive summary for the 2 projects? Do we have a bunch of graphs before we make it, or do we need to include graphs in it? Oh yeah, Caroline, we'll do that here next. You got it, Caroline. So with this right here, the 2 sample T, I would include this right here. Yeah, no, good stuff, right? The 2 sample T output, I would include this right here. Make sure to include both this graphic, and you might even include, it wouldn't maybe hurt. No, don't include that. Don't include the means ANOVA. I might include the quantiles on here. Graders should not take off for that. This is probably, I don't think we say that this is required, but if I'm going to include everything, if you've done everything, graders, I don't think this is on their thing to require. But I would include a screenshot of this up here at least, showing the distribution, and then I would show the output down here for the 2 sample t-test. So that right there. And the next question is the executive summary. Let's go talk about the executive summary and the future research again. So you're welcome, Martha. Thank you for asking about that. Make sure to have those screenshots right there. I'm going to bring up, so the reason I say again is I want to probably bring up the video I have because we're going to be ending off stars here in just a little bit. I got like a play all button now on this. So we're going to go over videos. I think I did it on the 15th. I did it on the 10th. Or maybe I did it on the... Oh, here we go. Okay. Let's go talk about this. I'm going to Brian Inception this. Let's go take a look here at executive summary and future research. Here we go. Little Brian Inception going on right here on the screen, but this kind of outlines just Brian, top of Brian right here. It kind of outlines what we need and what we want to get with our executive summary. You won't be including graphics in the executive summary. Make sure you're very clear, very to the point, and you work at this company, so you're just going to be like, here's what we're doing, here's what our company is, here's what we're researching, here's our objectives. But, explain it. Tell people what you're doing. Tell people the importance of this. And go through these steps right here for your company on what is being researched. I'm going to odd face right there. And so next, Brianception. Next, we're going to summarize important results. Give the numeric backing. You want to take your results and condense them down from your report and make sure to give the numeric backing, like give people the numbers. Here's what we found here. Here's what we found here. These are the numbers. This is what supports these ideas that we are having. Next, you want to give your clear ideas. I think a lot of times people lose points right here because they're not very clear in their objectives at the end. This has to be connected to your report. You're going to give an action item, at least one, to say like, well, we found out this about the students or this about the people we're researching. So we are going to do this action from this. So you need to be clear, be direct, and give an action. These are the 3 grading criteria by which you'll be graded by when the grader goes over your report. Outlines what is being researched. Summarizes important results. The executive summary gives a clear action item. These are how you'll be graded. Next, for the future research, when you're doing the future research right here, you only have one grading criteria. Future research examines new ideas that go beyond the report. So when you're doing your future research, you want to think about things that have not been covered in your report. Come up with some new ideas. Things that you could be like, well, we could examine this. This was talked about in the report, but let's go into further detail and start to flesh out this idea more. Let's try to bring new ideas into this. So when we're talking about our results, are we just summarizing the results from the graphs we did in the project, like the 2 sample? Exactly. Yep. So you're going to look at your whole report. Think about this. The whole point of the executive summary. So to Caroline's question, the whole point of the executive summary is that someone would actually not read your report. I know that sounds crazy, but if you're doing the executive summary right here, someone would not read your report. They could just read your executive summary, and then they wouldn't have to read your report. Does that make sense, Caroline? That we're in a different shirt. Where's my New York shirt? How am I bigger there? Did I change my camera angle or something? Probably. If somebody were to read your executive summary, they don't need to read your report. The executive summary is for executives who are like, I don't have enough time to read this report. Let me just read the summary of it. So you want to tell them what the report's about, first part. You want to then give them the important results of the report with the numeric backing. I can't state that enough. Great job, Caroline, right there. And then last but not least, you want to go down here and you want to say like, well, here's what we're going to be doing from this. Yeah. So the whole point of this is like, someone's not reading your report. Which you might say, why am I writing a report? Well, you have to give the report to give like the whole backing. And then this is like the Cliff Notes. Cliff Notes are so popular that they caught on that companies want a Cliff Notes now. They're like, give me the elevator pitch for your report. And then they're like, oh, I need to let me look at their graphs and stuff to see these supports for these conclusions. So you've got the backing in the report for everything you've done, but then you're going to take everything in your report and put it down into the Cliff Notes because the company's like, can you please just summarize this report? Can you make an executive summary? And then last but not least, the future research is going beyond. So do not just walk someone through your results again. Don't just be like, well, we saw this in the report. We saw this. We saw this. We saw this. No. That's not the point of the future research. The point of the future research is to go into new ideas, things we haven't talked about yet. And then we'll be like, well, we didn't examine this, so we should definitely look into this. We should collect data on this. We could put more money and time into this. It's not really an action item, but more coming up with new ideas, like the where do we go from here? Have some fun with it. Just come up with ideas. It's a little bit like a free form, but you're just trying and make sure to connect it to the report, though. I think this right here is very important. You don't just say like, let's start a candy company. Like, we're a tutoring company. What? So you want to connect your ideas to the report, but you can kind of have some fun with it. So I hope that makes sense there, Caroline. People look to be doing really great on the project. I don't think it's too bad. It's hopefully 108. Get it in by tomorrow night. With that, I think that's it. Thank you, everyone who swung by to Office Hours today. Office Hours, we'll be back here in just a little bit. Brian's talking in the background to Brian right there. But we'll be back with more Office Hours a little bit later. And gonna get ready for class. Until then, Puppet Shark. Bye for now, everyone. Bye!